Hello everyone and welcome to African Tech Gurus. This is your number one channel where we learn by doing. If you are new to this channel, please do us a big favor and subscribe to the channel. And also don't forget to hit the notification button so that every time we upload a new video and new content, you are immediately notified so that you don't miss a bit. We post our videos on different topics, and today we're going to be discussing Hello World, which is the project, and this is one of the very first projects in low-level programming. So please make sure you pay attention, and if you do have any question, please free to comment down below, and we will try as much as we can to get back to you guys. So now let's start. So I have clicked on the link and I had already opened it. So here it is. When you go into the link, there are so I have So I have clicked into it, and this is the page that you will see. So I want us to start with this very first one, which is the Excel, sorry, not Excel, the slide that they have, and it contains everything, and it's the same that is here. So these are the resources that they have given us. You need to read or watch this, and this is the most important one. Everything you need to start with C, and they have given us a comment. It's not a must if you don't understand everything, but make sure as you continue, you are able to understand everything. But today, please make sure you read it to the end. We will try as much as we can to cover it in the shortest amount of time possible and give you as much detail as we can. So let's jump into it. So this is the document, everything you need to start to know and see. I hope you can see everything you need to start to know and see. And I will put this to the side and I'll just explain it as we go. So the first thing that we need to know is what you see, why do we use C and all that. And let me share my screen. There's some notes I have been taking down and I have been researching on. So one of the things we need to know is that C was invented by a guy called Dennis Ritchie. And the most important thing after that is that it was invented and it was supposed to be and still is an imperative or procedural language. So what that means is that it follows a step-by-step kind of format, and that is one of the key characteristics of C. The other thing about C is that it is very efficient. So what that means is it is able to access the computer's memory and hardware directly because it is a low-level language. So a low-level language is one of the languages that is able to communicate directly or very closely to the computer itself and its hardware and its memory without necessarily hiding things or using abstraction, such which is commonly used in high-level programming languages. Yes. The other thing is that it is portable. So what that means is it can be used on platforms, different platforms, different devices, different websites, different applications, and it can be used without the need of compiling it again or working on it again. So it will be more of a pick, plug, and play. The other thing is modularity. So what this means is we are able to break down code into smaller pieces. So instead of writing one big chunk of code, C provides us with the aspect where we can break down our code in smaller pieces, and this helps us one, debug, and two, write the code. And it's also neat looking and easy to follow. The other thing is the flexibility that it gives us. And here we have the ability to manipulate data at a low level. At a low level here, the mean closer to the computer's memory and hardware. And lastly is here we need we need to declare the specific data types. So here, when we say strongly types, we mean we need to be very specific with how we specify our data types. So if we have an integer, we need to specify int. If we have a string or any other data type, we need to do that. I hope you got that. So the other thing that they also say here is all the code has to be inside a function, and we will see that later. So the very first thing that we need to understand is each and every C program must have a main function. It must have a main function, and the main function is always where each and every C program will start. So if your code or your program doesn't have a main function, it will not run. It needs to be there. And C files are source codes of our program. So this is where we'll write all our code, and that is the source code. This file will contain all the code that you need to use in our program. And lastly, let me reduce my size over here. Lastly, they're saying you have to compile C files with a compiler, and in this case, you're going to be using GCC to create an executable file. So I want us to go through the process of GCC and the steps that it's going to take. So here, when we have a file, let's say in our case we have main.c, and we run it using GCC as I have highlighted. I hope you can see that. GCC main.c. So here, when you put the command GCC, let me highlight it in a different color so that you're able to see. You can use red in this case. Yes. So if we run GCC main.c, and GCC stands for GNU, or however you say it. I say GNU or GNU. So it's GNU compiler collection. And when we try to compile the main.c file, we're able to generate an executable file, which is what they have said here. And it has 4 steps. Please make sure you understand these 4 steps, because if you don't, it will be chaotic in the future. So the first step is the pre-processing, and here it will run all the code and handle any pre-processing directives that are included in the code. So for example, if we have define and include, you can learn this. You can Google them if you don't know what they mean. We can also cover them in the future. So what it does, it will replace all the macros or any with their corresponding values and include any header files. So this hash include and hash define, these are libraries that contain more code. And this is standard code that is provided, standard library that is provided. And whatever they have here, the pre-processing step will pick them from their location and include them. I hope you get it, such that our program is able to run. So I hope you got that. The next step is compilation. So here the compiler will convert the pre-processed code into assembly language. And when you say pre-processed code, we mean the result of this step. I hope you see it, the result of this step over here. So the first thing is we run our code GCC. We run our GCC main.c file. It has been pre-processed and it has given us pre-processed code. And this pre-processed code contains more items. As you can see, all the macros will be replaced. So if this is a macro, it will be replaced with their corresponding values. I hope you got that. The next thing that will happen is, after the compiler has converted the preprocessed code into assembly code, that is our output. So in this compilation step, our output is assembly code. I hope you got that, assembly code. So the next thing now is the assembler now receives the assembly language code and converts it into object code. I hope you got it. It converts it into object code. And lastly, once the assembly step has already taken place and given us its output, which is an object code, it is now moved to the next step, which is linking. And here the linker will take all object files that have been generated. So one thing to note is that in this step, in the assembly step, it might not necessarily give us one object code. It will give us several object files that contain the object code. So as they are mentioning here, the object file generated from the previous step is combined into an executable file. So here, all these object files are combined or kind of put together. Think of it as the object files are the recipes to create the executable file. If you got that. And here, we also need to use any necessary libraries and system calls to link all these object files and create an executable file. I hope you got that. I hope you got that. So one thing that I want us also to have at the back of our mind is when you generate this executable file, it comes by default with .out. .out is the default naming convention that we will get. But you can specify the name that you want your program to, your executable file to be named. And here I am highlighting a piece of code that we have. Let me increase the size in case it is too small. So here I'm going to highlight this. So this is what we now need to run if you want to specify the name. And here we are using GCC, which is the compiler that you're going to use, as we have seen here, GNU compiler collection. And then -o. This -o means an object file. And the name of this object file is going to be called my program. And we are going to get it after running GCC on main.c file. I hope you got it. Main.c file. Sorry, I have minimized it too much. So here we are saying that it generates an executable file named my program instead of the default one, a.out. I hope you got that. Nice. So now we can move to the next thing, which are comments. Comments, let me reduce this. So comments, most of the time they begin and end with a / and an asterisk followed. And at the end it has a asterisk and a / And we can use this anywhere in our code, and they are not supposed to be nested. They would be nested and comments do not nest. And we use comments to be able to document our code. One, it will help us understand in the future when we are referencing our work what our code was doing. And two, it helps another person who is using our code or reading our code or even learning from it to understand what the code is actually doing. So for starters, we can look at this one that I have highlighted here. This is a very common program that we have over here. Let me increase its size, yes. So here we have the standard library that we're going to use, stdio, which is the input and output header file, and we use include to include it. And this int main is where our function, our program begins. Remember, as I have said before, any program will not start unless it has the main method or the main function. And this is our main method or function. And this is the comment I want us to look at, this one. So as you can see, it starts with a / and an asterisk and ends with the same. So when we are running our GCC or compiling our program, it tells the compiler that this is not a line of code, it can avoid it. And during pre-processing, before we get our compilation stage, all comments are removed because they won't be used to generate any assembly code. Now, the next thing that we have is the statement itself, and that we'll look at it later. Now, the next thing that we need to look at are variable types. Variable types. So here they are giving us a list of all the variable types and their sizes, and it is important because once you're able to understand the data types that we have, you will now be able to create programs with the memory needed to allocate it in mind. I hope you got that. So for characters, they always take 1 byte. And when we say just character as the first one, that means it is signed. So that means it is either positive or negative, and that is why the range is from -128 all the way to 127. And this in total are 256 characters. I hope you got that. And if it's unsigned, that means it is only on the positive side of it, so it will move from 0 to 255. So 0, if you include 0 all the way to 255, those are 256. And then for short, we have 2 bytes. For int, only please ensure you always know this. Each and every single integer always takes up 4 bytes. 4 bytes. And I hope you remember what a byte is. So 8 bits is equivalent to 1 byte. I hope you remember that. 4 bits is equivalent to 8 bits. 8 bits. And a bit is the smallest memory location. And bit stands for a binary digit. A binary digit. So when they're many, it's binary digits. So 8 binary digits help us make 1 byte. Please make sure you understand the difference between bits and bytes. So here a character takes up 1 byte, which is equivalent to 8 binary digits. And an integer takes up 4 bytes, which now will be equivalent to 8 times 4. I hope you got that, which is equivalent to 32 bits. Let me increase the size so that you see that. I hope you got that. I hope you got that. So please make sure you understand the concept of bits and bytes. And if you don't, we can definitely look at it again. So 32 bytes is equivalent to 34 bytes. I hope you got that. So the next thing that we need to cover is declaration. So when we talk about declarations here, we are trying to tell the compiler that we have a data type that is coming or an input that we need to use. So now let's move to declaration. So declaration is when programmers generally write the name of a specific variable in code and indicate the type and anything else that we want to specifically say. So when you say declaration of a variable, what you're saying is we want to determine the name and the data type. So this is the syntax here. We have the type that this data or this variable will have and the name of the variable. So I hope you got it. So here, for example, we have I, which is of type integer. So I can only take in numbers. I hope you got that. And here we have C, which can only take in characters. I hope you got that. And how we can name variables is there's a convention of naming variables. It can only contain A to Z, both lowercase and uppercase, digits 0 to 9, any digit, and any underscore. I hope you got that, and any underscore. Yes. So now I hope when you hear someone say they have declared a variable, what they mean. What they simply mean is they have said the name of that variable and the data type of that variable or any other argument or any other thing that is required of that variable. The next thing that we need to look at is arrays, and arrays are succession of items of the same type in memory. So what this means is if we have space in memory, let's say something like a shelf, and that entire shelf, for example, in memory, will be allocated to items of the same type. So here, for example, here we declared a variable called var name, and its type, we would say it, and the number of items that go in it. So here when we say it's a succession of items, we mean these items are the same, and they follow each other. I hope you got that. They do follow each other. So for example, when we want to declare it, this is the syntax. We need to write the type of this array, the name of the array, and the number of items it will take in it. So here is an example. Integer my array 32. So what this means is my array is the name of the array. It is of type integer and it will take 32 elements or 32 items in it. I hope you got it, 32 items. And the next one, and these 32 items, can only be integers. We can't put any characters or string, it can only take integers because we have specifically stated initially that it can take integers and should only take integers. The other one is character my array of arrays. So here you can have an array of arrays. So what that means is you have an array and then within it you have other arrays. And here, this array, my array of arrays, has 8 arrays, and within those 8 arrays, we have 16 items inside them. And these 16 items are of type characters. So they can't be integers, they can't be strings, they are characters. I hope you got that. So the next thing that they want us to cover is structures, and you can ask yourself why they want us to learn about structures. Because so far we have seen only specific types of data types, so either an integer or a character or a string. But what if you need to have a group of similar um, similar data types? Sorry, different data types. For example, if you're an individual, you have your age, you have your name, you have your height, you have your gender. All these things are related to one person. So we will need to find a way of um, kind of having this in memory or representing this in memory. So structures are a complex data type declaration that defines a physically grouped list of variables and are placed under one name in a block of memory. So all these things are supposed to be in one block of memory and they relate to one thing. So structures, if you're to give them a definition, they are group of several related variables that have been put in one place. And this one place is one block in memory. And each variable which is in the structure is known as a member of that structure. So for example here, when we are creating and declaring a structure, we need to use the keyword struct. And here we're creating this in the main function. So make sure when you're creating a program, the main function, as I have mentioned, needs to be present. And here we are using struct, which is the keyword used to create structures. And just like the previous data types, when we're declaring it, we need to specify its type. Here it's a structure, and we use the keyword struct and the name of the structure. So here it's structure underscore name. And now in the body of that, what will be contained in structuring will be now different data types. So for example, this is an example, a very good example. We've used struct, which is the keyword, and the name of this structure is called new underscore struct. Within it, it will have int a, character b, which will have 32 elements inside it. So here we are creating a new type called new struct. But when we want to just declare this is the syntax. Declaring is just as we have mentioned. I hope you remember. Declaring. Here we're just determining the name of the variable and the data type. So here we have already declared and created it. But if you want to just single out how we are declaring this variable of type new struct, this is how we do it. Struct new underscore struct s. I hope you got that. So the next thing that now we want to see is how do we combine arrays and structures together. So arrays of structures, basically. So here we have combined the arrays and the structures together. So here we do have struct, which is the keyword when we want to construct a structure, the name, and we are combining it with arrays. So here we have var arrays, which takes in 32 elements. I hope you see that, 32 elements. So this is an example of that. Here we have created a new structure called students, and within it, it's going to have different data types. So the first thing is going to have the first name of the student, and it will take in a maximum of 32 elements, and these elements are only characters. The other thing it will take in is the last name, and it will have a maximum of 32 characters. And lastly, it will have now another structure, which is now called address. I hope you got that. Address, and the array is ADDR. Because remember, an address also contains different data types. It will have the PO box or the postal address, which is now characters, and it will have values within it. Like if it's 101, that is the postal address, which is an integer. So here the address, which is a structure by itself, is contained within the structure called students. I hope you got that. So here we have a structure within a structure, and that is an array. So here we have combined arrays and structures. So that marks the end of today's concept. We will cover this. We will cover the next ones on the next video. If you have any questions, please feel free to reach out. Hope you have understood today's topic. We have covered how to declare variables, the different types of variables, arrays, structures, and how to combine arrays and structures. So until next time, have a good one.